Okay, welcome again to East Academia. So my name is Brian Modena, and today in this video we're going to talk about Greek symbols. So my name is Brian Modena, just right here. So welcome to my YouTube channel. This is East Academia, and if you've not subscribed, kindly make a point to subscribe. And if you find this video helpful, share it. So today I'm going to talk about what we usually use in mathematics and even in engineering. And many people have told me maybe to show them these symbols before I continue with that series on calculus. So first, mostly we use Greek symbols to mean different things. Like I said in the previous video, where in the introductory video, that these Greek symbols have different meanings. So the names of these symbols are as follows. So the first symbol, so these are Greek alphabets, and these alphabets are nothing but letters, okay? So these are letters. And normally, even in Greek, we have capital letter and lowercase, small letters. Small letters, or the capital letters are the higher case, and then the small letters are the lower case. Don't know what type of English is that, but I think it's British English. So the Queen's language. So again, so let us get straight to the work. So the first letter, of course, is letter A in English, which in Greek is known as alpha. So the small letter is that one, and the capital letter is that one. So this is known as alpha. So I will start with the small. In fact, I think I should just make a table. It will be easier if I make a table. Let me see if I can have some. No, let's just proceed that way. Of course, this one might take much of our time, but I'll just draw a table. So I'll just have a table that way. Yeah, so I'll have. So this is the lowercase, this is the uppercase, and then this is the name. So the first one, which is the first alphabet, this is how it's written. Okay, and this is known as alpha. And then the second one, this is how it's written. And then the capital one, and this is known as beta. Oh, what's happening? And then the third one is this one that is written this way. It's like a Y, but it's not a Y, okay? And then its capital form is this way. And this is known as gamma. So just the same convention. So, and then from there, we are having the one that I told you, that one. Then the uppercase is that, and this is known as delta. And then we are having this one, looks like an E. Then the capital is that one, and this is known as epsilon. Epsilon. And then we have another one that I usually, okay, it's written something of that kind. And then its capital is this one, and this is known as zeta. I think I'll just have to proceed this way. And then from zeta, we have another one that usually represents efficiency. Its capital is this one, and this is known as eta. And then we have another one. The capital form is just funny, but I think something of that kind. And I think this one, you must have interacted this one. This is nothing but theta. And then these other ones, okay, I will just mention the most important ones, because the other ones I find them a little bit not necessary when it comes to this course. So I'll just say whatever necessary. I won't teach you all of them. I'll just teach you whatever necessary, because especially the ones that have a mathematical engineering meaning. So the other one that I'll teach you is this one. Which is lambda. And then we have this one. This one is known as mu. Some people call it mi, but so I usually call it mu. And then we have this one, ni. Okay, or nu. Some people call it nu. Depends where you come from. Okay. And then we shall have the next one. This one, I think, this one most people know it. This one, you know that symbol, don't you? Yes, I know you knew it. I knew you knew it. That's one common one. This one is pi. And then there's this one also. This one is a very common one. And this is rho GH. And then we have this one. And this is small, this is capital. I mean, this is small, this is capital, and this is sigma. I'm just going to show you the most common of these symbols. And then we are going to have another one that is commonly used is this one. And its capital is this one, and this is tau. And then we have the other one known as epsilon. It's like a V, but somewhat whatever. And then Y, capital, and then this is known as epsilon. Okay, these are usually used. That's why I've seen the need of you knowing them maybe. But these are just used as symbols, okay? So they shouldn't give you a headache to cram or to do what, but it's good for you to know them anyway. And then we have now this one. Usually write it that way. And then it's capital, it's okay. And that one now is known as phi. And then we have this one. It's capital. This is known as chi. Or other people call it kai, other people call chai, whatever. But I usually call it chi. And then we have this other one, which is the one that I usually love, because I usually use it in then it's capital. I usually use it in there's a question known as a Schrodinger wave equation. Usually use this one. Then this one is psi or psi. And then I'll just have the last one for this series, the one that I think are important. You can go for the other ones, but I know. So the last one looks like that, and this is omega. Okay, so before we conclude, we can just have a visit and see how these symbols look like. So I said this is my lowercase. So let me just highlight that. So I said this is lowercase, uppercase, and the name of that symbol. Okay. So you said the first one, you can see how alpha looks like. That is, it's an equivalent of A. Then you can see beta, you can see gamma, you can see eta, you can see theta, you can see lambda, you can see mu or ni, you can see ni, you can see pi, you can see rho, you can see sigma, you can see tau. Okay. In this case, I think we'll have to rub whatever is unnecessary because it can be a little bit confusing. So let me just rub whatever is not included. So sorry for this. I mean, this is not supposed to be here. This part, this, but this is just a complete O. And yes, okay. And then epsilon, we have phi, we have chi, we have psi, we have psi, and then we have omega. And then let me look at these other ones that I left. Then we have delta, we have epsilon, and then we have zeta. So basically these are the Greek symbols that will interact with them. If you ask me to give an engineering meaning, let me try my best and let's see what these things mean. So what exactly does alpha mean? Alpha usually is used to represent angles, okay? Actually, not only alpha, but I'll just... alpha and beta, these ones are usually used to represent angles when it comes to engineering and mathematics. So for example, if you are told to, you can label an angle that way, or you label an angle that way, or you can even come and label an angle, let's say this one, beta. Okay, so alpha and beta usually represent angles. And then when you come to gamma, mostly I've used gamma in telecommunication engineering, and what gamma usually represents in telecommunication engineering is basically a reflection coefficient. Okay, reflection coefficient. But also in some cases I've seen people using gamma for angles. Okay, so you can have an angle that looks like this and you call it gamma. Same thing to theta. Okay, this theta is usually used to represent angles. Okay, theta. Okay, and then also the same theta usually can be used for temperature, where you can say theta T. It can be used for temperature. So I'll just have to say here. Just have to say here, maybe temperature. It can be used to represent temperature. So for example, theta 1 means temperature at time 1, and then theta 2, which can be our final temperature. So let me see another one. Lambda. What does lambda? Okay, lambda is usually used to represent wavelength, isn't it? It usually represents wavelength. Wavelength, like for a wave, I mean, this is the distance from crest to crest. Like for example, for those of you who have done physics, you'll know that a wave is usually represented, a sine wave looks like that, isn't it? Now, the distance from a crest, because this is a crest, now this is what we call a wavelength. That is the length of a wave. That's usually represented by that lambda, isn't it? So let's say from this distance here to this distance, we can call this distance lambda. Or also it can be a distance from a trough to a trough. Trough, no, it's the deep. So from here, let's say from here, which is usually equivalent to that distance from this point to this point. Okay, so let's see if I've left out anything. Yeah, I think I've left out this one. So this symbol here, okay, this symbol here, sorry about that. So this symbol here, this one, eta, is usually represents efficiency, and it's usually, especially when it comes to power systems, to circuits, this ether here usually represents efficiency. So, and the efficiency usually given us the output power over input power, or rather output quantity, the output quantity. So it's usually output quantity. It can be anything. Output quantity over the input quantity. So it's output over input. So for example, you put in 3 people. You tell 3 people to do certain work, and you say 3 people. Now that's an input. 3 people, isn't it? And then they carry how many blocks? They carry 10 blocks. So what is the efficiency? The efficiency is 10 over 3, isn't it? So the number of input that you're putting over them. So that's efficiency. So you'll get into that later on. And then let's see what else, which other symbol. Okay, this one, Ni. Ni can be used to represent an angle. Ni can be used to represent an angle. And then let's come to this other common one that most of you know. Okay, the one that is very common for us, and I cannot lie, is pi, because pi is a constant, isn't it? Pi, but the smaller one is the one that is common, and this usually is represented as 22/7, which is nothing but 3.142 something. You can just use the calculator here and see. 22 divided by 7, 3.1428, all these numbers, all those numbers that you are seeing in the calculator over there. So those are pi. And then you can come, now let's come to the next symbol. The next symbol is rho. The next symbol is rho. Now rho usually is used to represent density. Yes, rho is usually used to represent density. So rho, this one represents density, especially the smaller one, density. So when you see density, usually represented as rho. Some of you know that pressure is given as rho GH, okay, where this is density, gravitational acceleration due to gravity, and this is height, okay. This is given the height, isn't it? The height. So rho, this symbol rho, usually represents density. Okay, and then the other symbol that you are seeing is sigma. So the sigma, okay, sigma, okay, now this sigma, both of the small symbol and the capital one, okay, the lowercase and the uppercase, all of them have a meaning, because this uppercase one usually is used to denote a summation, summation, isn't it? This is a summation sign. Add, addition, isn't it? So if you are told in engineering said I from I is equals to 1 to n, isn't it? And then you are told it's 3x plus 2, and then you have an I here. That means this will be a summation when I is 1, I is 2, and let's say maybe here n is 10. when I is 1, when I is 2, when I is 4. So what you do, okay, let me just explain. I mean, it will be a long video, but it's good for you to understand what these things mean, because they'll assist you eventually to understand engineering mathematics. So what this means is, for example, if I say I is equals to 1, this means that I begins from 1, isn't it? 2, and then the number that is put on top here, n is equals to 3. It means that I goes up to 3. So I will be 1, 2, and 3, isn't it? And then I'll say 3x I plus 4. So this means basically this can be rewritten as, so basically this one is used for contraction. So this can be written, this summation sign means that it is 3x1 plus 4 plus 3x2 plus 4 plus 3x3 plus 4. That's what it means. Okay? So that means wherever there's I, now you replace I with 1, 2, 3. So instead of writing this long mathematics, you can just contract it and write it in this format. And that's why these contractions are very important. They save you time, they save you money, they save you calculation. And then maybe now you can be given the values of x1. I told x1 is 1, x2 is 3, and then x4, x3 is, let's say, 2. Then I can substitute the values. So where there's x1, you're going to put 1, and then multiply. Where there's x2, you're going to put 3, and then where there's x3, you're going to put 2. Then now 3 times 1 plus 4, so this will give you 7. Then 3 times 2, this is 3 times 3, I mean 9. 9 plus 4, this gives you 13. And then x3 you're saying is 2, so it will be 6 plus 4, this will be 10. So 10 plus 13, that is 23. 23 plus 7, this is 30. So you see. So basically, this means summation. It's a summation sign. Okay, and then let's go to the small sigma. So the small sigma also has meaning, but mostly it's used to represent an angle. Okay, so the small sigma usually represents an angle. Small sigma usually represents an angle. And then now, so this one represents an angle. And then you have tau. Tau represents transmission coefficient, which I think you will know later. And then now you can go to epsilon. Epsilon I haven't used it most of the time, but when it comes to these two, these ones, both uppercase, both their uppercase and lowercase are usually used in differential equations to denote quantities that value, or rather to represent waves, isn't it? So for example, like in the last video I said that you can write something like this. A wave can be written in this form. A wave usually represents a wave, okay? So a wave, which is a function of omega, which is a function, omega represents angular speed, isn't it? So let me just, maybe I should answer this first. So this one represents angular speed. Angular speed is how fast something rotates, isn't it? Isn't it? So angular speed is usually written, is the derivative of theta over time, isn't it? So how fast something rotates. So this is what gives us that one. So angular speed, so this is a function of angular speed, and this one, and then you can say this one is 3 sine, then I'll have sine omega t. So I can just say that I can write a wave in this form. So I can write a wave in this form. where this wave is a function of angular speed and time. As you can see, omega can change, time can change, and so forth and so forth, isn't it? In fact, the next video I'll show you MATLAB simulation of this, how this one can be written, isn't it? And omega is usually given as 2 pi f, isn't it? Where f is nothing but the frequency. So f, just bring here, where f is nothing but frequency. Okay, and this frequency is usually obtained by 1 over t, where t is nothing but the period. Now I think I'm getting too much into waves, but we shall stop there. I just wanted to show you how this one. Then this small omega, I've not used it for quite a long time, and I can't remember exactly what it means. So let's come to this other side. Delta, like I said, we use it in differential equations. Okay, so delta, we use it in differential equations, especially this symbol, the one that usually converts to capital D, something of that kind. And then later we'll see this delta can also use it in it has some engineering significance. And then this one, epsilon, usually represents permittivity. It's usually used to represent permittivity. Let me grab real fast. Sorry about that. So this usually represents permittivity, and then zeta usually represents an angle. Okay, one thing I'll tell you is that these symbols cannot, as in, there's no need of cramming these things. Okay, these symbols cannot really be defined the way you want. I mean, anyone can define these symbols the way they want. Okay, anyone can define these symbols the way they want. Like, for instance, if, for example, I want to define, like, for me, when I want to write a mathematical equation, I usually define these symbols first. I usually, and most engineering textbooks and mathematical textbooks usually define these symbols. So you can already be told where. So you can be told that a wave, let me just write here, a wave is written as then after it's written, you are told where. They usually write there, where this one represents angular speed. So most of the time you are going to be told what these things mean. So there's no need for you to be worried about it. Okay, yeah, there's no need for you to be worried. So that's why I'm saying it's good for you to just know what something means, what it means, how it means, and how you can go about it. Okay, so I hope you found this video helpful. Please don't forget to subscribe and share this video, and have a nice time. Thank you so much.